Hello and welcome to another one of my thoughts videos. In this one I want to go back to some very basics and set some more foundations for other topics. I've been wanting to touch on these topics but I kept on going back and back. They're very interesting topics and we're very privileged to have the information, understanding and application, the knowledge of these topics, and so I want to just set some foundations here. It all started a few years ago with my cup of coffee. My wife was trying to get slimmer and cutting back on her sugar, and so she started criticizing me on the 2 teaspoons of sugar I was taking in my coffee. And I didn't go with that one. I said, no, I'm not scared of sugar or anything like that. I know a lot of people are, and so I decided that I'd better get myself better acquainted with the science of it to have an intelligent discussion with these people who were saying that sugar was so evil. So I went into a whole bunch of research and study, which you also can do, but I'll sort of condense it here for those that aren't wanting to do that or don't know it already if you're a young person or something like that, and to give a bit of a roundup for those that do know these topics. Excuse me and bear with me and be a little tolerant of my delivery and my understanding also. Now, it's all about concepts, as we have discussed in many times over, that you must gather knowledge, information, and a lot of the information that we have today, even though we are restricted in what we are able to have access to as normal Joe Blogsers, we do actually have a lot of information that other centuries have never had. And a lot of the concepts that we are privileged to have been lifetimes of work of some people. So we should be grateful and we shouldn't take it flippantly and treat it flippantly, and we should appreciate this amazing knowledge and this very fascinating stuff. Now, the concept I want to lay the foundation for, which builds and builds into a massive number of very interesting things, is that of positive and negative. Now, I'll take a step back and say, with concepts that people have worked on a lot, take the number 1. That's a concept. It's an object, a one thing. There's only a unit. You can sort of, I don't know, smoke something or sit on a rock in the countryside and contemplate 1. And then if you have another 1, you get 2. Now, those are concepts, 1 and 1, and there are a concept of many. There is also the concept of adding them together, and we represent those things with a language which seems pretty universal around the world. 1 plus 1 is 2, and it's really a language. Now, a lot of the time through history, people like Einstein and others, particularly physicists, are treated with great respect because they have great big blackboards full of numbers and signs and brackets and formula and all these sorts of things. But unfortunately, we tend to place them on a pedestal higher than they should be, because these are physicists. Really what they're dealing with is our concepts. Now, this all wraps up into an explained language, as it were, called math. Now, maths actually has very little to do with numbers. We use numbers, but math is just a language, a shorthand language like Chinese, Arabic, Japanese and French and English is a language to explain something. It's a shorthand language that most of the world actually can speak. Except there are tribes like the Piaroas on the border of Venezuela and Colombia where their math is limited to 1, 2, 3, 4, 5, many. They don't add, they don't subtract, they don't do anything except count to 5 because that's the number of fingers on their hand. So their math language is very limited and basic. But all of these mathematical equations like MC equals MC squared, the famous Einstein one, are really just language, symbols, shorthand to explain concepts. Now, the concept of, I was just explaining, of 1 plus 1 is 2 is basic math used to do concepts or to explain or write down very shorthand concepts. Now, for many centuries, not for many centuries, only in the last century, have we known about the smallest concept there is in the universe of positive and negative. Now, I was born 6 kilometres from, no, I was raised 6 kilometres from where Sir Lord Rutherford was born in Brightwater, New Zealand. He was, they say, he was the first to split the atom, but that was not actually what, according to what I found out anyway, was not his claim to fame. His claim to fame was the idea of electrons. Now, the basis of everything we can see, touch, feel, and even what we can't see but are physical, are reliant on this positive and negative, the idea of atoms. And now the periodic table is a very amazing piece of lifetime's work. I think it was originally done by Russians. Not more than a century ago, I think. A little bit more than a century ago, I think. Where even electrons weren't even developed or confirmed or theorized by then. In high school, in chemistry classes, they said, here's the periodic table, memorize it. And I go, oh, how boring, what was that for? And in actual fact, I wish they had told me what it was actually about and told me the concept behind it. Because it's a very, very important table which can explain a lot of things that all you chemists out there will understand. But for those who are not chemists, excuse me, chemists out there, I'll try and explain it as basically as I can so that those that are new to this can understand it. Now, before we get too far, I have to explain that the concept of positive and negative is attraction. This is what holds the whole universe together. When you get a positive and a negative, you get some attraction. So opposites attract. Positive and negative cancel out and become stable. That even happens in marriage, I think. But when there's a positive and a positive, they repulse, they push away. And when there's a negative and a negative, they also push away. The important thing, though, is attraction. Now, it's this positive and negative effect, this attraction or repulsion, which holds the whole universe together, yet separated into its solid and gaseous and other states. Now, there are a lot of things that are not physical that are therefore affected by this, but this is where we've got to start building on explaining my cup of coffee and sugar. Now, at the very basic and minimum of everything, there is a neutral something called a neutron, and it's got a no sort of attraction as such, I think, and then you get a proton which has a positive attraction to it. So you get them clumping together, and that begins this nucleus of your basic atoms. And then Sir Lord Rutherford, I think it was, or somewhere around there, discovered that there were to balance this positive, there was a negative whizzing around, orbiting those two in the nucleus. Now that is your most basic of atoms, and that atom is hydrogen. It has a proton, a neutron in its nucleus, and it has a negative electron, an E for electron, orbiting that. That is your first and smallest of your atoms. Now, starting with 1, you've got 1 neutron, 1 proton, and 1 electron. 1 electron. The next atom will have 2 protons, 2 neutrons in its nucleus at the center, and it will have 2 electrons orbiting. And that one is called helium. Hydrogen, helium. And when you get to 3, you get 3 protons, 3 neutrons, and because of those 3 positively charged protons, you're going to have 3 negatively charged electrons zooming around it. Now, they found after several decades of investigating that around that nucleus there is only space for 2 negative electrons to whiz around. Then it makes a second layer where the third one is going to go. The first ring, or the first layer, has 2 in, and the next layer has space for holding up to 8. And so the next one you get is lithium, and when you get to 4 protons, 4 neutrons, and 4 electrons circling in 2 of them, 1, 2, 3, 4 negative electrons, you've got beryllium. And so it goes up to, I think they've counted up to 118 protons, 118 neutrons, and therefore 118 electrons circling or orbiting in various different layers. Now, just the 2 layers, and maybe even to the third, are ones that particularly interest us in general life, because our most common elements are in those sorts of groups. Now let's take a look at just back to hydrogen, which is a neutron, proton, and 1 electron. Normally with the attraction, that concept of attraction, positive and negative, you get a nice balanced atom. It has another space for another electron if it was forced to. Now, you can at different times force another electron to orbit that, but then it gives that atom now a negative charge, because those 2 cancel, that's neutral, then it gives it a negative charge, and that's where you have something that's with ions, that's ionized. Now, if you have a proton, 2 protons, 2 neutrons, and 2 electrons, excuse that, it's not a positive, negative, orbiting, you can also at different times force that electron to leave the atom as well, and then it becomes positively charged. Now that accepting and giving up of electrons complicates things and makes things interesting. Now the interesting thing is that when you have an atom, say a hydrogen, which is a proton, neutron, and 1 electron, the layering of things, you can fit 2 in the first layer and 8 in the second. And so the extra space here, that if necessary, as I just said, you can force an atom into that space to make it negatively charged. It can do that by sharing an electron here. Say you have another hydrogen, which is a proton and a neutron, with an electron. Well, they can both share. Now, there are 3 atoms which are very important to us. One is that hydrogen, which is the single electron. Carbon has 6 electrons, and oxygen has 8. That means a carbon atom will have its nucleus, and then it will have 2 electrons on the first ring, or the shell, the first shell, and then in the second layer of electrons it will have 4 electrons. That means that there are now there are going to be 4 spaces that it can share with other atoms. The oxygen, it has its nucleus with its 2 electrons, and then on the outer shell it will have 6 of its 6 electrons, 1, 2, 3, 4, 5, 6, and it means it will have 2 potential places to electron spaces to share. Now this is very important to us as far as my coffee is concerned, how fuel, energy, gasoline and all sorts of things rely on these 3 atoms with those 2 spaces in oxygen, 4 spaces in carbon and 1 in hydrogen. Now the fact that hydrogen has its nucleus and 1 electron and 1 space, and an oxygen has got 2 spaces and 1, 2, 3, 4, 5, 6 negatives. One of the very important things to us is that a hydrogen can share the space with the oxygen, and that makes a water molecule. Now, carbon also has its usefulnesses because of its 4 spaces, but the oxygen and the hydrogen. Hydrogen is what our sun uses and what most of the stars are made up of, as being the lighter of the atoms, with less electrons, protons and neutrons. They're lighter and take a lot longer to gather together and form clouds, which then burn into our suns and stars. Then as things got further on in history, the oxygens and hydrogens can join to make water, and at the Great Flood, our atmosphere, which was composed mostly of oxygens and hydrogens apart, the forcing of the sharing of those makes it into water. And also, lately I've found some very interesting things about water as well. So there you have the very basic concepts: proton, neutron, making it a positively charged, then an electron circling on that, and according to the number of protons and neutrons you have in your nucleus, therefore how many electrons circle it gives you the different kinds of atoms, and therefore the different things like gold, silver, beryllium, all sorts of iliums and things, all of the elements that we have. The most important ones for us at the moment is the hydrogen, oxygen and the carbon atom, and that is the basis of fuel. And I'll leave it here and digest that, the concept of attraction of electrons and protons that then generate some very interesting combinations of atoms that become very interesting, including my cup of coffee.